Hey, good morning, everyone. We're going to look at a special case where we're solving, but with an x to the second power in it. So we've been solving when it's just x. X to the second power has its own special techniques that we have to worry about. But before we can do that, I want to make sure we're clear on one property of multiplication. So let's say I did 3 times some number and said it equals 0. Well, in this case, it would have to be 0 because 3 times 0 equals 0. Or if I did 11 times some number equals 0. Well, once again, 11 times 0 is 0. So the big thing I want to emphasize is that, in case you weren't familiar with this, whatever is in this first set of parentheses, if I multiply it by 0, I'm going to get 0. And it turns out that this basic property is super essential when we're talking about how to solve when an x squared is involved. All right, there's a few things we have to keep in mind. When we're solving with an x squared, part of it is going to be we have to factor completely. Another piece is we're going to have to make sure that our expression is equal to 0, and we'll take a look at that in just a second. And what's real interesting is when we're solving with these, there could be no solutions, there could be one solution, or there could be up to 2 solutions. So basically, this exponent clues us into how many solutions there could be maximum, but there could be less. All right, so in this case, take a look at example 1. I had to edit my work here. That's x squared minus 2x minus 63 equals 0. So if we take a look, number 2 there is true. We have equals 0. And so we're in good shape. So now I'm going to take a look at factoring. There's just a 1 in front of x squared, so I don't have to worry about pulling out a greatest common factor. So now I'm down to thinking, here's my box. I've got an x squared, got a negative 63. Factors of negative 63, well, of just 63 are 1 and 63, 3 and 21, or 7 and 9. All right, so I'm now thinking about this minus 2x, so I know my factors are going to be x and x for x squared. And thinking about which of these numbers could possibly combine to get me a negative 2, I'm thinking 7 and 9 is probably going to work. But because it's a minus 2x, I'm probably going to need a negative 9. So let's give that a go. So remember, positive times a negative is going to be a negative. And then 7 times x, negative 9 times x. So that's going to get me x squared plus 7x minus 9x minus 63. And sure enough, 7x minus 9x will be a negative 2x, so we're good. All right, so all I'm going to do now is say, I took this, I factored it. Here are my 2 factors. So instead of this trinomial equaling 0, we're now just going to write that its factors equal 0. So all we did was factor and then said this times this should equal 0 since the original trinomial equals 0. Cool. All right, so now the question becomes, what could go in for x to make this thing 0? And in this case, there's actually going to be 2 possible answers. Oops. All right. So the first case, I'm going to say that negative 7 is a possibility. And let's see what happens. So if I put negative 7 in here and here, negative 7 plus 7 is going to be 0. Negative 7 minus 9 is going to be negative 16. And remember, our original property says 0 times anything is 0. And so this ends up checking out. So if x equals negative 7, that's one solution. In another possible case, let's go back here. Gonna run out of room here. All right, so in this case, same thing, but now I'm gonna worry about this. So some number minus 9 should be 0. Well, if I put a 9 in here, and I put a 9 in here, now I'm gonna get positive 16 times 0, because 9 plus 7 is 16, 9 minus 9 is 0. That equals 0, that's also good. So x equals 9 is also a solution. So for that problem, we get 2 solutions. So basically when we factor, this set of parentheses makes it easy to figure out, oh, what numbers are going to make the whole thing 0? So we worried about the first set of parentheses in the first case, and then we worried about the second set of parentheses in the second case. All right, so that's the big idea. By making it equal to 0, we can quickly find the solutions that work. All right. So example 2 is a little bit different, just because I see a number that isn't 1 in front of x squared. So before I even try to factor my binomials, I'm going to see if I can factor out a number. And I'm betting that all of these have 3 as a factor. So 3 times 1 is 3. 3 times 14 is 42. And 3 times 33 is 99. So sure enough, 3 is a factor of all of them. So the first thing I'm going to do is just divide out that 3. To get that much simpler thing to factor. All right, so now I'm ready to factor. And some of you might already see what it factors into. So I've got an x squared and a positive 33. X times x is x squared. That's good. Then factors of 33, 1 and 33. 3 and 11. Remember, I'm looking for factors that can possibly combine to get 14. Right away, I'm looking at 3 and 11. And in this case, everything's positive, so I'm betting that each of these numbers will have to be positive. So 11 times 3 is 33. That checks out. 11 times x plus 11x. Positive 3 times x is positive 3x. And we can check it out. Does it work? Sure enough, positive 3x plus 11x will be 14x like we want it to be, so our factoring is good. And so let's use our factors here. So now we know that we can rewrite this as x plus 3 times x plus 11 equals 0. But what I can't forget about is, remember, we pulled out this 3 at the beginning. So that's just going to come down and follow us. All right, so same as the previous example, I want to know what numbers could go in for x to make all of this equal to 0. Well, basically, in other words, we're saying that 3 times some number plus 3 times that same number plus 11 should equal 0. Well, if I'm adding 3, I'm betting if I put a negative 3 in here, that's going to work, because negative 3 plus 3 will be 0. So this will become 3 times 0. Negative 3 plus 11 will be 8. Well, if it's multiplication between all these, 3 times 0 is 0, times 8 is still 0. So this checks out. So x equals negative 3 must be one of the solutions. And then let's go think about the other set of parentheses. All right. So now let's think about this case. What number plus 11 gets me 0? Well, that would be negative 11 plus 11. And if I put in a negative 11 here, I'll now have 3 times negative 11 plus 3 will be negative 8. Negative 11 plus 11 will be 0. Well, 3 times negative 8 is negative 24, times 0 is 0. So this checks out. So that must mean that if x equals negative 11, that's also a solution. All right, so that's all there is to it. So once again, we're factoring as much as we can. This case, I had to pull out a number at the beginning, and then I factored like normal. And so here's my factored form. And then I'm finding out what two x values make the whole thing equal to 0. Cool. All right, we're going to look at one more case, and then I'm all done. All right, let's move on down to example 3. What you'll probably notice in this case is that it does not equal 0. And so what we're going to do is we're going to get rid of the terms on this side to make it equal to 0. So if I subtract 4x to the second, or 4x squared, this doesn't have an x squared, this doesn't have an x squared, but this one does. So if I'm taking away from both sides and following my rules, this will now just be 1x squared. Or I can just write it as x squared. And then I still have a minus 7x plus 12. And now on this side, this became 0, leaving me with just a positive 30, or I can say 30. But still not equal to 0. It's closer. Now it equals 30. But I want it to be equal to 0. So since it's a positive 30, let's take away 30 from both sides. All right, that's going to get me x squared minus 7x. And now I have positive 12 minus 30. That'll be negative 18. Equals, well, 30 minus 30 is now 0. So now I have something equal to 0. Now I can start solving. So this is critical to make our multiplication property work. All right, so let's go ahead, let's factor. All right, I got my x squared, I got my negative 18. So factors of 18, 1 and 18, 2 and 9, 3 and 6. So thinking about what numbers could possibly combine to get me 7, right away I'm jumping to 2 and 9. But it's a negative 18, so one of them's got to be negative. I want them to combine to negative 7, so I'm guessing the 9 will have to be negative. So x times x is x squared. Let's try it. Minus 9 plus 2. 2 times x will be positive 2x. X times negative 9 will be negative 9x. And negative 9 times positive 2 is negative 18, so that's good. So now I've got x squared plus 2x minus 9x minus 18. Positive 2x minus 9x, that will be negative 7x, so we're good. All right, so let's write it out in our factored form. So we now have x plus 2 times x minus 9 equals 0. So what makes this true? Well, some number plus 2 times that same number minus 9 has to equal 0. Well, in this case, if I throw a negative 2 in, negative 2 plus 2 is 0. Negative 2 minus 9 is negative 11. Do those multiply to get 0? They do. And so x equals negative 2 is one possible solution here. Running out of real estate. All right. Cool. And once again, let's check, make sure there's not another solution. In this case, there is. So I'm trying to find one more number that makes this equal to 0. Well, I already dealt with this side. Now let's think about what would make this 0. Well, some number minus 9, I'm betting that's a positive 9. 9 plus 2 is 11. 9 minus 9 is 0. Well, 11 times 0 certainly is 0. And so x equals 9 is our second solution. All right, and that's all there is to it. So basically what we're doing is we're using our factoring skills and then using our, I guess, reasoning to find a solution skills to recognize that there could be two solutions in this case. So give it a go. If you have questions, don't hesitate to reach out. And I look forward to seeing you again soon.